Hey everyone, welcome to my last stream on this Global Hack Week, where I have been featuring a series of events focused on rack systems and recommendation systems, which are all related to AI, vector databases, and embeddings. I know there's plenty of buzzwords in there. To be honest, I have been basically explaining all of these concepts throughout the course of all my streams. So for the stream today, I know I mentioned on the Discord that you won't need any previous experience, or there's no need for you to have watched the other previous streams, because I'm going to be explaining everything from scratch. Maybe not very in depth as I did on the last streams, but I will give you an idea of what we're talking about. So for today, we're going to be building an extra feature for our cool application so you can have a project, and then you will be able to make more pull requests on that same repository so you can feature your own features on that repository. And let me tell you that I already approved a pull request from someone that contributed to my LLM benchmarking application like about a day or two ago. So if you want to contribute as well to open source projects, this is also one opportunity that you can take in order to learn about these types of things. Before we get started, as always, don't forget to check in. The link is over there on the chat. That's your way of getting the points for the weekend. So make sure that you check in to get those points secured. This is officially the last day for Global Hack Week. We will be having closing ceremony tomorrow. There's also plenty of things prepared after that. I believe that there's also another stream coming up like in a couple hours. So feel free to tune in for those. Right. So during this stream, I will be sharing all of the resources that we have been using through these series of events. But let me just first start by introducing myself. My name is Jocelyn Velarde. I'm a coach here at Major League Hacking. I'm based in Mexico, but I'm currently based in the US because I'm working on a research internship in neuroengineering. So that's my current location as for the moment. Some of my fun facts is that I like salsa dancing, which I haven't done in a while, and I definitely miss that. I also collect bee plushes in general. I study robotics, so you can talk to me about robotics. I'm also starting to make content on Instagram, so if you want to follow me in there, I post things almost daily about competitions, hackathons, events that you can attend, forums, and so on. So if you want to tune in for those, make sure to follow me in there. As well, which is super unrelated, but that's true. And I also announce my streams whenever I'm going to be streaming. So if you want to be up to date with that, also feel free to follow MLH on Instagram as well. All right. So I know it's Wednesday, so it's honestly a weird day. In my opinion, I always feel like Wednesdays are almost Friday, but not Friday. Because I'm thinking about Thursday. I have meetings tomorrow and I have work as well. And I just want to reach Friday because maybe I'll go see a movie, which would be cool. It's actually the first time that I would go to the movies by myself. Friends have told me that it's really nice. It's a very unique experience. So maybe I will try it, and I will go by myself. I have gone to other places, by myself, like eating places or local cafes, but I've never gone to the movies by myself. So I would say that that's a bit different. I will update you if I eventually end up going on the next Global Hack Week to see how the experience was. All right, so leaving the side topics aside, and also feel free to bring up any side conversation on the chat or anything that you want to ask me about the coaches program, any hackathon, GitHub Campus Experts, or the fellowship itself. Feel free to drop your questions on the chat at any moment because I love seeing side conversations going on in there. Okay, so this is actually an update from the previous streams that we have been doing. But for today, we don't have that much of content, so maybe we will wrap up a bit early if we don't have any issues with our code. We're gonna be adding more features into our dashboard, and these features are gonna show the user query in a 2D plot of vectors. Then we're going to use Plotly library and scikit-learn in order to use these components. Then we're going to learn about PCA, which is a technique of used in vectors and also in math. You'll see what I'm talking about, and we're gonna update all of that in our current project that we have. And my goal after this session is that you will have the rack project finished with a new page where you will be able to visualize the vectors that you're actually embedding into that plot. I know I mentioned a lot of different words and a lot of the different concepts, but I'm going to explain everything really fast. I'm just going to go through some slides super quick. Then I'm going to jump into the code, show you the setup. I'm going to give you a couple of minutes for you to build your own setup. And then I'm going to start writing a new section of code, which will be super short. We're just going to create a new Python method to the current library that we were having. And then I'm going to be adding some other front-end features so we can visualize our plots, which, to be honest, it's really simple. I have to admit, this is not super beginner friendly, but I will do my best to explain everything. And if you end up being confused at any point, don't blame yourself, blame me for not explaining it correctly. And if you want more clarification, you can always drop your message on the chat. We are not here to judge. So even if you ask me like, oh, what is a vector in LLM, or what is an embedding, or what are you referring by this? There are completely valid questions, and I will treat them equally. We have a hi there, nice to see you. Great. So let's move on super quick. I'm gonna jump into this plot. I know I've been repeating myself throughout all of the streams, and if you've been to all of my streams, I'm so sorry for you to be hearing the same explanation all over again. But I just want to make sure that all of the hackers that attend the stream are on the same page. So for today, we have three words or three definitions that I really want you to be clear about. The first one is embeddings. So embeddings is basically like you have a sentence or you have a word and you want to convert that into a numerical representation that you can plot somewhere. This is the actual pipeline used for embeddings. So we have our sentence in here. Then we use embedding model. Then that embedding model is basically different vectors that store embeddings. And those vectors, we can plot them in a two-dimensional space. So in past streams, they had this debate about how can we actually plot in a 2D space? Is it a multidimensional space, and so on? So yes, embeddings, they are multidimensional vectors, but for this stream, we will be treating them as two-dimensional vectors with a technique that we will be learning in order to plot them. Because, as humans, we cannot interpret more than 3 dimensions. If you are able to interpret a fifth dimension, then you're not human. And I don't know what you've been up to, but we can only see up to 3 dimensions. So this is how vectors in like our actual world work. But then when you try to see it on a more AI perspective, you will see that this is actually multidimensional, but we only like to represent that as a 2D dimension so we can actually see them somewhere. And this is my goal today, to make this nice graph where we can plot our embeddings and see how related they are. But for now, you should know that embeddings is a numerical representation in vectors of a sentence or just a regular word that you can type in as a string. Okay, that's our first concept. Then the next concept that we're going to see, I'm skipping all of these, but if you want to see the explanation of the whole slides, make sure to see the stream about building your rack system and recommendation systems part 1. They're all in the YouTube channel from MLH, so you can watch the recordings in there. Might be relevant to explain this graph where we have all of our embeddings grouped here in different clusters, depending on how related to each other they are. Again, embeddings, they represent the semantical meaning, not the exact lexical sentence or word. It's mostly the meaning that we are trying to plot. Another important thing to mention is vectors in terms of CS. So basically, We can think of vectors in two ways. So we all know because of physics that vectors is a set of numbers representing both a magnitude and a direction. In CS, we like to represent it as an array of numerical data that is not of fixed size, so it can vary on size. We can see just how it can be plotted in this image over here. So right now we've seen two things so far. We've learned about embeddings, which are the numerical representations that create these vectors. Then we learned how can we actually represent a vector in CS, which is super simple and straightforward. And then we're also going to learn about cosine similarity. Cosine similarity is just a measure to measure similarity between two vectors. So if you're talking about recommendation systems or measuring similarity between two things, which in this case are going to be two vectors, we are using this technique called cosine similarity. This technique, it's only a simple formula. Well, it's not simple, but it's just a formula that receives two vectors. In this case, my two vectors are A and B, and then we perform a set of operations in order to get our relationship. Let's keep in mind that the output for cosine similarity varies between -1 and 1, so you will only be getting numbers depending on the relationship that are inside that range of values. Important things as well to keep in mind: cosine similarity is not the only measurement that you can use to measure similarity between two vectors. There's other techniques that you can use, like Euclidean distance, and I think there's another one. But there's more techniques that you can use. In our case, we will be using cosine similarity because it's the one that we already configured on MongoDB, and I'm going to tell you exactly where to configure that if you were not present on the past streams. What else? In actual practice, talking about code, usually you don't need to calculate cosine similarity yourself in the code, like create a Python function that's cosine similarity. Usually the databases that you're going to be using, they already have this functionality in their system. So you only need to select it and then it's going to start working for you. So there's no need for you to like create the method for this, but it's important to know how it works because we will reference these. Well, it is already referenced on our code, so you can now understand where it actually comes from. We have a question here. Will we be using Jupyter Notebook or write Python in VS Code? We will be using Python in VS Code because we are building a dashboard in Streamlit. But yeah, thank you for asking. This is just an example that I placed for past streams about creating our own embeddings. I'm not going to be going through this today, but just keep in mind that when you are generating embeddings, we are talking about different embedding models. So depending on the model that you choose is how the different dimensions that you're going to get on your vector. And this QR code or this link are just for you to visualize those embeddings. So the code is very simple. I just place a sentence and then I see how it actually translates to an embedding. So you can see how a natural language sentence can be translated into an array of vectors as we are trying to apply these techniques. Right, and then the last concept that we're going to be learning before moving on to the new stuff for this part 2 of the stream is a rack system. So a rack system basically integrates all of the words and all of the concepts that I've been mentioning lately. You can see a rack system as a regular chatbot that has access to a personalized database. So if you want to customize your chatbot to answer questions very specifically about a custom database, then you want to apply a rack system. I know it's different, that I can basically train an LLM just by adding a system prompt in there, and then it will be answering in a certain way. But if you actually wanted to get access to data, then you will need to create a vector database where you will have your embeddings, where you will be basically fetching from. So the pipeline is, as I am showing on this picture, we have first our user, and the user, of course, it will ask a prompt. That prompt will go through a retriever, and the retriever will basically search if there is similar content on our vector database, and it will fetch specific documents that are related to that search. After retrieving the context, it's gonna join both the prompt and the context that it retrieved from the database, and it's gonna input those two things onto an LLM. This LLM can be any model of your choice. It can be Gemini, it can be ChatGPT, DeepSeek, any LLM that you can think of. And finally, the LLM will basically draft a really nice polished answer with context that goes back to the user. RAG is it's basically retrieved augmented generation, and we can see where the R comes from. You know, you're retrieving from a vector database, and the A comes from augmented because we are mixing both our prompt and our context. So add the retrieved information to the user prompt. And finally, we have the G, which means generation, because we are generating a new answer. We are generating a response to our user with the context that we basically received from our retriever stage. Um, Maybe this pipeline might seem a bit blurry, but the more that you see it and the more that you put it in practice into actual code, you will see how everything just plugs into place. I would say that right now this is one of my favorite topics to explain in terms of AI. I just feel that it's something really powerful. I wouldn't say it's really new because this concept has been out there for a while, but you know, it's always good to learn and know how to implement these types of systems so you can also learn and create and apply them on your own projects. I have to tell you that from my personal experience, I have applied a rack pipeline into our robot from my robotics team. So basically, in the competition, there's this section where the judge can ask any question to the robot about context on the team, on the university, or on the robot itself. So instead of just creating a super large prompt, I created a database with and trained, well, not trained, but included a lot of documents on that database about like our web page, the documentation for our robot, the events that we've been to, our university information. So now when the judge asks those types of questions, it can actually go ahead and look onto that database and respond with really relevant information. And you cannot just see it as a regular database. So we're not talking about, oh, I just upload all of my text to a database and then just fetch it from there and input that as a system prompt to my LLM. That's not how it actually works, because the information that I'm uploading into my database is in the form of embeddings. So it's just numbers. And I'm going to show you how this looks like in actual MongoDB. So you can see what I'm talking about when having your own context in there. Right, so let's just move on. This was everything that I wanted to show you for the past streams. Here's a more detailed graph that you can see. I also shared this presentation before. I will be sharing the GitHub in a couple minutes, so you will be able to access the slides from that GitHub repository as well. All right, so now we will be moving to the new content for the part 2. So thank you for all of the hackers that were present on the past streams, and this is actually new content that we're going to be learning for today. Sounds cool. In a previous stream, I mentioned that my team is looking to build a rack-based chatbot from a university. Sounds very similar. Oh, this is really nice. I don't recall you mentioning that, but now that you're bringing this up, that will be really nice because you can basically store all of your university's information on MongoDB on a vector database, and then you can just have your chatbot answer in relevance of that context, which is basically the exercise that we built on the last stream. So on Build a Recommendation System Part 1, we actually built the RAG chatbot and we put it onto test, and it was really accurate, to be honest. But for today, we're going to be doing something similar, but still not the same. So we're not going to be doing a chatbot. We're going to be doing a semantic plot. So to learn about semantic plot, which I'm just going to give a fresh brush up on the page that we already have built before. So the first thing that we did is that we used MongoDB vector index search to do cause and similarity for us, so to know the relationship between our vectors. Then the second thing that we did is that we used Gemini 2.5 Flash as our LLM base, so for the generation stage of our RAG. And then we created this RAG chatbot where hackers basically place personal information and show the knowledge base to everyone to recommend like or to ask questions about specific hackers. So I'm gonna be sharing that screen with the current with the current dashboard that we basically built, so you can see how it works, and then also visualize some stuff in MongoDB. Just give me a moment to divide my screens because as I mentioned, I don't have any monitors right now with me, so it's a bit sometimes it's a bit hard to be doing a stream and having to be seeing like many tabs at the same time. Now where is this? Okay, here it is. So let me remove this one and add this one onto stage. Don't mind this. This is only the AI Studio. I'm not going to be going into that today. What I want to show you is the application that we built. And I'm going to send you the link so you can also test it as well. This is a link for you to access the same page that I'm viewing right now. So this is a project that we built on the past stream. It's really nice. It basically has a chatbot in here, and you can upload knowledge to the chatbot to MongoDB, and then you can ask questions about that, and it will basically retrieve it. To give you a bit of context of what do I have on my knowledge base right now, I'm going to go into MongoDB and I'm going to show you exactly what I'm getting. So I'm just going to log in super quick, sign in to show you the current documents that we have in there and how they actually relate to each other. So you can see where the information for the chatbot is coming from and also visualize like the embeddings that we're seeing. Let's see. In the meantime, I have to tell you that all of my slides, I generated nano banana images about Minecraft bees. So hopefully you like them. I tried to make them like in the theme of the stream. So they're really nice. I might be updating my profile picture soon with one of those that I found. I'm gonna tell you which one it is once we reach that slide. Right, so in MongoDB, we did a couple of things. I'm not going to go in very in depth about how we configured everything in MongoDB, but I'm going to show you the most important thing. If you want to see how we configure MongoDB more in depth, feel free to check the previous stream on RAG, building your RAG system, which was about a week ago. It should be on the YouTube channel as well. Most important thing is configuring our search index in MongoDB. Why? Because this is the actual thing that's going to be performing the cause and similarity. So it's going to tell you how similar our vectors are. In this case, this is my index in here. It's called Vector Index Global Hack Week. It's getting the vectors from Vector Store database and from the collection embeddings stream. If you're familiar with MongoDB, you should know that in MongoDB, you have different databases and each database can have multiple collections. And in the collections is where the actual content is stored from. And each element on MongoDB is called a document, and a document is just basically a JSON object. In here, we can see the type that we are using. In this case, we are doing vector search. Let me see. Edit with JSON editor. So in here, it's all of the configurations that I use to configure this index. So number of dimensions of my embedding model is 768. I'm going to explain this further along. And for similarity, we're using cause and similarity, and we are using vectors. So this is what we already talked about. In order to measure similarity between vectors, we need to apply a specific mathematical formula. And in this case, the formula that I'm using is cause and similarity. I'm just going to exit this. It is very important that when building a RAG system, you must have a vector search. So something that will be interpreting your vectors and tell you how similar they are to each other. MongoDB manages these through indexes, but if you're using something else, like there's also ChromaDB for embeddings, there's also Pinecone for vector databases. They manage these differently, but they all have these cause and similarity functionality because that's just a standard among vector databases. And then to show you how it looks like, I'm going to go ahead and browse collections so you can see the current database where the application is reading from. I'm going to go to, I believe it's this one. Let me check. Yep, it's this one. I'm gonna make this a bit bigger so you can see them better. So my database is called Vector Store Database, and my collection is called Embeddings Stream. Sorry, I just ate, so and in here I basically shared the app to hackers, and then they were updating context about themselves. So for example, we have Leo in here. Hi, my name is Leo. I'm studying CS at Ball State University. And then another hacker wrote, I want to learn more about search recommendations. And then I wrote one myself. Hi, my name is Jocelyn. I do streams at Global Hack Week. I also work as a cloud developer, blah, blah, blah. And then many hackers were updating context. So if you actually go right now into the page and upload your own context in here from the page that I just shared with you, I should be able to see it in here on my database. And for the embedding section, we have a field called embedding that if you see, it is an array of 768 dimensions. If we open these, we should be seeing all of the numbers in here, and there's even more fields that we can show from the embedding. So these numbers are the actual magic where all of the calculations are performed in order to calculate the similarity. And these are the numbers that we're going to be using today in order to plot all of our embeddings and see how similar they are to each other using different techniques as well. So I just wanted to show you how it actually looks like. We have another in here. Hi, y'all. My name is Mandy, and I love dogs, and so on. Oh, I actually didn't see this one, which is really nice. Great. So if you want to go ahead, you can upload your context in here because we're going to be using it. So I'm going to go ahead and try it again. So I'm going to upload a new user. So I'm going to call myself, hi, my name is B. I love flowers, and I also like eating chocolate. I recently tried salty chocolate. And I'm gonna upload these to MongoDB. It's gonna be processing, and then it's gonna be uploaded. And then if I refresh my database, and I should be seeing that in here on my collections. Let's just give it a moment for it to refresh. Okay, so it's in here. Hi, my name is B. I love flowers, and then so on. And then we have someone else who uploaded. Hi, my name is Varsha from India, and then looking to create a RAG-based chatbot this hack week. Awesome. So now if we put it onto test on our chatbot in here that we created on the past stream, I'm going to ask who is from India, and then we will be getting some context related answers, and then we should be able to see where it actually got the source from. So the response from the LLM is Sawik and Pasha are from India. And then if we see the sources, we are seeing our top 3 sources. So number 1 is Sawik, who mentioned that he studies in India. And then we also have Pasha that mentioned that she specifically is from India. We can also ask it different things, like for example, who likes nature? Then it should be able to retrieve information about people that mention stuff about nature. So we have Anaid likes nature as she built a Lego set of 2 cute plants. That is actually true. I have my plants in here. It's really nice. And then the new user that I just uploaded, B, also likes nature as she states she loves flowers, which is basically what I just said in here. And then if we see the sources, we see those 2 documents pop up in here. And then we also have Mandy as well that loves dogs, which is, similar to nature. I didn't see this. I love learning from Jocelyn during Global Hack Week sessions. That's so nice. I don't know if Mandy is watching this stream, but shout out to Mandy for these lovely shout out to me. Great. So now to move on with this, now that you are able to see what an actual vector database looks like, and how you can how can you apply this into like your actual chatbot? It's really amazing. I want to share the code for this specific project. I'm just gonna explain super brief, like what is the code, and then we're gonna jump into learning about the new stuff, and then we're gonna start coding like the new section. We should be able to be adding a new page in here so you can swap from the RAG chatbot into the plotting section. Great. So let me jump into GitHub right now so I can share with you that code, and you can start setting up your environment as well. So if I go to repositories and then RAG template over here. So this is the one that I'm going to share. And I have to update the README, by the way. It's outdated. I should be getting that done probably today. Not sure. Okay, but the important thing that you want to see from here is both the home page and the backend page. There's only two files, so it's super straightforward. Let me first go to the backend because that's where all the RAG information is. In here, I'm just declaring some global variables, my Mongo URI in order to connect to my Mongo cluster, my database name, my collection name, and my vector search index. Then I have this first method that's called get vector store. This one is basically creating the vectors. So it's creating all of the embedding. So all of the weird numbers that we were seeing, this is a method that's actually doing that. And we're using this specific embedding model called all-mp-net base v2. I want to explain a bit about embedding models in the slides, but just for you to keep in mind that there's different embedding models, just as there's different LLM models that you can use, and they all work differently for different applications. At first, I was using the Gemini embedding model, but then I changed to Hugging Face embeddings, which is an open source model that you can access. After that, I have this method ingest text. Ingest text is just basically to upload our document into MongoDB. And finally, we have this method called getRagResponse, where all of the RAG logic is actually included. So I know that I've been talking for a really long time about RAG and all of these things. And then if you see it at the end, it's a super short and simple method. So there's nothing complex about this. We are doing our vector store. So we are doing our embeddings here. Then we are declaring the LLM that we're going to be using. In this case, we are using Gemini 2.5 Flash. Then we are declaring our retriever. So basically, how many documents are we going to retrieve from our database? And in this case, we are retrieving 3 documents. And then we basically just do the search into our database. Finally, we craft our prompt for the LLM. So we are passing our prompt from the user, which is our query. And then we are also passing the context. So the context is the top three documents that we're going to be fetching from our vector database. Finally, it creates the LangChain chain and it returns it in format of answer and sources. Because if you see in our chatbot, we are not only getting an answer, but we are also getting the sources about where the information exactly came from our vector database. Right, so that is all from the code. I'm not going to be explaining the homepage because it's just, it's some front-end code using Streamlit. If you see, it's really simple. I don't like using complex frameworks. One, because I'm not really familiar with them, and two, because I really suck at them. So I usually use Streamlit as my base for cute dashboards. And if you can see, it looks really nice. I mean, it looks like for an app that you just built that you just want to demo. So it's something fast and simple that you can deploy as well instantly. Great. So let me stop sharing this screen. Now that you have context about what we built and what we're going to be adding, we're going to be seeing some technical concepts as well. So now about the embedding model. As I mentioned, we are using this specific model from Hugging Face. And if I go over here and show you, so in here, we are using this specific sentence transformers model, which is called all-mp-net base v2. And if you can see, it says this is a sentence transformers model. It maps sentences and paragraphs to 768 dimensional dense vector space and can be used for tasks like clustering or semantic search. In this case, this model is suitable for us. Why? Because it has a 768 dimension, which is what we specify on our MongoDB index search. And then it also mentions that it is used for semantic search. And what we are doing in our application is that we are doing semantic search because we are trying to find similar things that match this sentence in here. Great. So hopefully this was clear. If there's any questions about the code or the application that we have, feel free to let me know in the chat. I know it's a lot to take in for the first time, so it's completely okay to be confused at some point. Then moving on, we already talked about cause and similarity, so I'm going to be skipping this slide for now. And then we're going to be talking about our raw vectors. So we already talked about vectors and embeddings, but then we also want to know how do they actually look like. So my goal for this stream is for you to visualize those vectors into a plot. Right now, we are using this model that has 768 dimensions, but we are humans, so we cannot visualize that with our own eyes. So the way that we solve this is with math, of course. So we're going to be learning a couple of techniques applied in math that we can use in our code in order to simplify these so we can have a really nice plot with our embeddings and we can see all of the clusters and how they actually look like. And shout out to this image that was generated by Gemini, which is really nice, who got the perfect shape of a Minecraft bee and is representing embeddings in there. Honestly, I'm just very surprised by the amount of quality that Nano Banana has reached in the past few weeks. It's just amazing. Like, you cannot even tell if it's AI or if it is true. Yeah, just that just amazes me. It's just really impressive. But okay, let's move on to the next one. So there's just in order to simplify these 768 dimension vector, we need to first talk about k and n, which is k nearest neighbors. This is a technique used in machine learning. It's mostly for clustering and also know which point is more like near each other. And in our code, we are actually applying k and n technique. If you see in the code, there's a specific section where we are selecting our top 3 documents. And if you recall from the page that I recently shared with you on the Streamlit, if you try it on and type something in the chat, there's actually information that we are retrieving our top 3 sources. So MongoDB is actually applying a sort of K and N algorithm for us, because we are telling our system to perform a 3 nearest neighbor search. But MongoDB, instead of using K and N, which is expensive, it uses another technique called A and N, which is basically an approximate, so an estimate to what actually K and N is. And to make a reference, I'm not going to be explaining very in depth how A and N works, but you can imagine this as if you walk into a huge room looking for people who like Star Wars. So if you were KNN algorithm, you were going to ask every single person like, hey, do you like Star Wars? Hey, do you like Star Wars? And then go each by one until you find someone that actually likes Star Wars. And for A and N, which is our vector search that MongoDB is applying, we are looking for the group of people, for example, wearing Jedi robes or wearing a t-shirt that says, I love Star Wars, and not just walking straight to them. So this is a nice reference that we can use in order to know the difference between KNN and ANN. And I also placed this image so you can remember about Star Wars bees, and it has a nice lightsaber, and we can also see the Death Star on the background with a Minecraft bee, which is a very interesting crossover. But in that way, by relating this reference, you can remember what MongoDB actually uses in order to get those top 3 results for us. Right, so now that we learned about how MongoDB does the top 3 things, then it's time to learn about principal component analysis, which is also known for PCA. PCA is basically a simple 2D or 3D scatter plot. PCA is a technique to squash the 768 dimensions of my vector to just two dimensions. And if the dots are close together, they are semantically similar to the AI way, basically. So once we do our plot, if we see that two points are near each other, then that means they're semantically similar. So the RAG will be most likely to give that response because it's similar in their plotting. PCA is the actual math technique that we use to reduce the dimensions of vectors. So from n dimensions, you can simplify to just two dimensions, which is what we're going to be building today. We're going to be using this technique in our code in order to make that graph look really nice. Great. So just to finalize before we start the code, this is the pipeline that we're going to be following. So number one, we're going to be getting user inputs. Number two, we're going to be converting those inputs to conversions. Number three, we're going to be performing K and N in MongoDB, which by the way, this is done automatically from MongoDB. So there's no need for us to do any coding there. Then we're going to be coding the function for principal component analysis, which is what we're going to be building. And finally, we're going to be using Plotly in order to make our scatter plot so we can visualize these into a 2D array. Great. So the title is not correct. Yeah, I forgot to update this. So let's just stick with this. This is going to be our plan for the day. Let me stop. Let me stop. Well, I will remove this one and then I'm going to share a new screen. Keep in mind that I'm not going to be sharing. I'm just going to share this one once we finish our functions. So I'm just going to jump back into VS Code and then we will be doing like all of our code in there. Let me share my screen. I have my project in here somewhere. Has to be here. Yep, here it is. So here is the actual VS Code. I'm gonna just fix my screen so it's a bit smaller and we can see it a bit better. Keep in mind that I already shared all of this content. So all the code that I have in here, I already shared it with you. It's on the GitHub repository. You can access it from the chat. Let me just let me highlight it. It's this one. Now I'm just going to give you a couple minutes for you to do your project setup. So if you need to clone the repository or preferably fork it, so you can fork the repository and add your functions in there. And then perhaps you can also make a pull request if you wish. So I'm just going to give you a couple of minutes for you to do the setup, maybe go and see the code for yourself or ask any questions that you might have. And then I will come back and we will start doing a function and then also some front-end code in order to add this scatter plot into our dashboard. All right, so I'm back. So we can continue. Well, so we can start with the project. I'm gonna be removing the banner so you have more visibility. And then let's just start. So the first thing that we're gonna do, we already have some. I'm gonna be closing here. I'm gonna be working on this backend .py code, and I'm also gonna be pushing this regularly into the GitHub repo so you can see the updated code in case that you don't want to fork it yourself. I'm gonna be into this backend .py code, which is this one. I'm just gonna make it a bit smaller so you can see it better. And now, in this case, we're going to be adding a new method that we're going to be using for the backend code. So this new method, we're going to use it to visualize our vectors as we want them. So if we go in here, let's just go a bit down. This is the last, let me make the terminal smaller so you can also see it better. There we go. So in this specific section, we already have this function that it's to get a RAG response. We also have the one to upload the document to MongoDB. And then we also have the other one, which is to convert from words to embeddings using this model that we have in here. So the next thing for this new feature that we want to add, wow, it's actually reading my mind. Yeah, I'm gonna tap for that, but then I'm just gonna snooze Copilot so we can also give it a nice explanation in here. So this function is going to be called get vectors for visualization as Copilot was already suggesting, and it's going to receive a query, which will be a prompt from the user that we want to plot. So this method, in shorter words, it will return the vector of the query and also the vectors of the top results so we can finally plot them. So for this, we're going to do something similar as what we're doing on the RAG. So we're going to create a variable called vector store where our vectors will be stored. And for that, we're going to be using the get vector store method that we basically created over here, which is just basically fetching the embeddings that we have on our database, and it returns those into this variable. So I just called it the same for simple terms vector store. The next thing that we're going to be doing is that we want to embed the query that the user is giving us. So for that, I'm going to create a variable called embeddings where we're going to be storing these. Then I'm going to use vector store. Then I'm going to be dot and embeddings. There we go. And then the next thing that we're going to do is I'm actually going to embed the query. So query vector, I'm going to call it that way, that variable. I'm going to use the embeddings variable that I just created in here that has the vector store embeddings. So embeddings, and then I'm going to do dot embed query. So this is a function that's already in there. I'm just going to use it. So embed query, and the embed query, it's going to receive a parameter that it's going to be the user's query, which is this one. So this parameter. So we're just going to be passing query in here. Great. And then the next thing that we're going to be doing, we might want to fetch the top K documents. So apply K and N. We might fetch the top 5 documents for visualization. So we're gonna be able to do that. So we're gonna create our retriever just the same way that we did in here. So I'm just gonna copy paste this line. But instead of retrieving the top 3, I want to retrieve the top 5, so we have more stuff to plot into our plot that we want to see for more visualization purposes. So I want to change my K. Instead of 3, I'm going to change it to 5. There we go. And then we're going to do exactly the same that we were doing in here. We're going to invoke that query. So I'm just going to paste that same line in here. Nice. And then the next thing that we're going to do, it's going to change a bit from this one. So I'm going to create an array or a vector that will have all of the data. So it's going to be called doc data. I already created that. And then for each document that we have in our docs, so the information that we are fetching, we want to have our vector in here. That's going to be embeddings dot, again, we're going to use the embed query function. And we're going to be passing, in this case, each content that we have on our same page. So we're going to be using this one, doc, which is for each element, and then we're going to be passing, I believe it's the content, so page content. There we go. And then we're just gonna append all of our doc data so we can create JSON format. Because again, all of this stuff that's stored in MongoDB is in JSON format, so they're JSON objects. So we're gonna have our content. In this case, the content is gonna be our document that has the page content. So let me see, page content. Then we also want to have our vector. So that's the key. And then the value is going to be back. And finally, we're going to have the type of document that we're going to be storing, which in this case, it's just going to be a regular document, right? So we already have our data in this format. So the way it's going to be stored. And now what we're going to return from this function, so we can use it on our front end. We want to return the query vector so we can plot it. And this is called exactly the same. So query vector, which is this one that we already got from here. And we also want to get the document data from MongoDB. So doc data. There we go. Oh, what? Oh, I'm missing a command here. There it is. Okay, so this is a method that we created for the visualization of the vectors. I'm going to go ahead and push these into GitHub so you can have access to that code now. Let me just add these, added method for vector visualization. And then I'm going to commit this one. And then I'm just going to push it in here. There it is. So now you should be seeing this updated method on the GitHub repository in case that you want to access it for a better view, or if you have more questions, you can also see it from there. Great. So we already finished our backend code. Now the next thing that I'm going to do is that we're going to use this function, but now in our front end. I'm not going to be adding this graph into the same homepage. I'm going to be creating a new page on our dashboard so we can visualize everything in there. So to do that, to create a new page in Streamlit, I'm going to create a folder that has to be inside here. So I'm going to create a new folder that's going to be called Pages. It has to be called Pages so Streamlit gets the actual dashboard that you're trying to build. And then inside Pages, I'm going to write the name of the page. In this case, I'm going to call these vector graph. Vector graph.py. And then in here, we're going to be basically starting all of our code. I'm just going to grab I'm going to grab, well, we can do it from scratch. I'm going to close these and we're going to start in here. So importing Streamlit, our first thing to do. Then we also want to import our backend code, which is this file. So all of the functions. We're going to be importing that backend code as our RAG. So we can call it RAG when we import Streamlit as st. There it is. We also want to import pandas because we're going to be using import pandas as PD. Wow, I'm just typing really bad. Import pandas as PD and plotly as well. Import plotly.express as px. And we also want to import sklearn for using the principal component analysis, as you remember. So sklearn dot, I don't remember where it was. Let me just see. Decomposition might be import PCA. Awesome. Then I'm just gonna do some basic page configuration, such as adding a title in Streamlit. We're gonna call these vector visualization. I'm also gonna add a subheader. So view your embeddings in a nice plot that uses PCA. Great. So now we can actually start with the code that we want to use. So this was just some imports and then some setup of the page. I'm also going to add a divider in here so we have a line between our title and subheader between all of the content. So the first thing that we're going to be receiving, it's going to be a query from the user, which is the query that we're going to embed, and then that embedded query, we're going to plot it into our two-dimensional plot. So we're going to create a variable called query, and then we're going to convert that variable into a text input. So we will be receiving text input for the user. So the text will say, enter a query to visualize it. That's going to be our query. And then we also want to have a button. So when the user clicks the button, it generates the plot. So if the button is pressed, is if st button, and the button is just going to say a plot. What we want to do is that we want to use a Streamlit spinner. So the things that actually, like the circles that show for loading. So a spinner, and that spinner is going to say calculating reading from 768 dimensions to 2. So we can see the loading page. And then the first thing that we're gonna do is that we're gonna get, I'm gonna add a comment. So get data from backend. So to get the data, I'm gonna create a variable so we can store the data to later plot. We're gonna call our backend that we named rag over here. So rag dot, and the function that we care about is a function that we created. So the one called get vectors for visualization. And what we're gonna be passing is a query. And the query in this case is this variable, right? So query in here. There we go. So far, we are fetching, we are sending this query from the user into our backend, so we can convert that query into embeddings and then relate itself in MongoDB using the cause and similarity approach. The second thing that we're going to do is apply the PCA, so the principal component analysis. We are going to fetch the list of vectors, and then what we're going to be doing in here is that we are going to be converting from like the 768 dimensions to just 2. I don't know how to do this because it's super weird, so I'm just going to be activating Copilot for this section. Let me pause this and see if it actually applies the PCA. Let me just see if it's actually correct. Contents, item for item in data. Okay, this looks legit. All right. Okay, so in here we're applying the PCA, which is essentially what I wanted to show you. Oh, my bad. And it's doing, well, it's doing all of the code for us. I'm just gonna do it because I don't know how to do plots, so why not? And we can just walk through it. This is the most important thing. So in here is when we are applying this function from the skitlearn library. There's no need for me to do all of the calculations in order to do the PCA. So I'm just going to call it in there and we can use it in there. So PCA, number of components 2, because we are plotting two-dimensional. And then this is just for plotting. So we are creating a data frame, and that's why we are using Pandas library. In here, we are plotting these into X and Y for the content. And then we are using a scatter plot. A scatter plot is the type of plot that shows like the points. So we will be able to visualize these in nice plots that we can be seeing as well. So the one thing that I don't like about this is that maybe by not using an interactive chart, it might not be really nice. So maybe I'm just gonna delete this and I'm gonna tell it to use px scatter plot. Just gonna say use px scatter. Okay, let's see. Okay, so now this one is gonna be now this one is gonna be an interactive plot, because the one that we had before, it was just gonna be an image, and now we are using this interactive plot that is natively integrated with Streamlit, so we can actually hover and we can see like the annotations, and we can also like make it smaller or make it bigger. And then finally, when it plots it correctly, it's going to show a success message saying that it was done. Great. So with that, it's the only front-end code that we're going to be needing in order to visualize these. So I'm going to be uploading these into GitHub so you can see it. Finished uploading with. There it is. So I'm just going to commit this, and oh my God, no. I was going to commit my what was commit commit stage until let's commit. No, changes on stage. Why is it not on staging? The thing is that I was about to commit my how do you call this, the let me copy paste this. I was going to commit my secrets file, and then I was just gonna get my credentials revoked, and I don't want to have that. View stash. No, I don't have stash. On stage changes, commit, undo last commit. There it is. And then I'm not gonna stage this one. Just a vector graph. There we go. Now we can do git push. Okay, so the code should be now on the GitHub repository, so you can see this one. And now I can go ahead and run these applications so we can see how it looks like, and we can also test it out. So to run these, I'm gonna make this smaller so you can see the command. So to run your Streamlit application, you wanna do a Streamlit run, and then the name of the script that you wanna run. In this case, my homepage is called home.py, so I'm just gonna run that one. And now it's gonna open like a new tab with the project that we just built. So while it's doing that, let me see if you have any questions. So we have a question in here saying, "Hi, quick question about the fellowship. I'm currently 17, but I'm in my second year of uni. Can I still apply if I have a parent's consent?" Yes, there should not. Oh, you're 17 now. I'm seeing. Sadly, you have to be 18. The reason why is because you're gonna be receiving payment, so it's gonna be a stipend that you're gonna be receiving for us. And in order for you to receive that money, we actually need you to have, your bank account and everything set up so you can receive like that into your account. It was also my case. I was also 17 when I tried to apply, and then I had to wait like for a whole year in order to like participate in a fellowship. I'm pretty sure you don't have much left for you to turn 18. So just wait until you're 18 so you can send your application. I'm not sure if a parent's consent will work. I mean, I can ask, I guess. You can send me a DM so I can ask about this, but I'm pretty sure that the answer will be no. But we can try. And yeah, I mean, in the meantime, you can start preparing your application. You can do a demo application, like see what they ask you to do, like check your essays. You can improve your project, have a nice readme, good contributions, and so on. So when the time that you apply, you have a really strong profile that you can apply with. Hopefully that was helpful. So I'm gonna now show you like the page that I just ran. I'm just arranging my screen, so just give me a moment. Okay, so I'm gonna show you the one that's in localhost, and then we're gonna see how the one that's deployed looks like. Because one cool thing about Streamlit is that when you do a change in your GitHub repository, it will automatically deploy it into your application. So this is the one that I have in localhost. It has the regular rec system, but if you see, we now have a new page that's called vector graph. So I'm going to go over there into vector graph and see what's going on. It's probably going to take a second the first time that it's loading. Right now we can see the title. So vector visualization, view your embeddings in a nice plot that uses PCA. We have our divider, and then we have our text and the query that we're going to be trying on today. So for a bit of context about what we're going to be doing in here, I'm going to be typing a sentence or a query, and it's going to plot it into a two-dimensional space according to the other vectors that we have in our MongoDB cluster. So it's going to show me the relationship between all these vectors that we have in here. So let's just type something like, I'm from Mexico. And we're going to click on plot. Calculating from 768 dimensions to 2. And let's see what it actually looks like. It's taking a while. String indexes. Oh, I know I shouldn't have trusted Copilot on this. Let me copy this, and I'm gonna ask, like, hey, this is happening. Can you fix it? I don't want to be swapping screens too much, but basically what I'm doing right now is that I'm just asking my internal Copilot chat on VS Code for this error message. But another cool thing about Streamlit is that you can also click in here on the Ask Google or Ask ChatGPT for you to answer those questions. I mean, my guess in here is just something related about the plotting that we did, because we already had something configured one way, and then it just basically changed a bit. So let's just give it a second for it to get that done, and then we should be seeing what it will be getting in there. Let me see. Okay, so this looks kind of legit. Let me try this. Okay, so it should be fixed now. Let me try refreshing the screen so we can see the updated stuff. And I'm also gonna push the code. If it works, then I'm gonna just push the code so you can see the correct version in there. Let's see. Oh, there was a file change. Oh. Right, so let's type the same query from Mexico, and let's just plot this. It's taking a while again. Name and I forgot an import. NumPy import. Let's do our import NumPy as NP. And then let me refresh it again. I already made the change, so I'm just going to be refreshing the page so you can see it. It was just a missing import, so hopefully we can fix that now. I'm from Mexico. And let's do plot. Let's see if we can see that plot now without mistakes. Hopefully. Okay, it looks like it's there. So we can see here our semantic distance map and also our success message saying that the plot was generated. So my query is in here, the I'm from Mexico query, and then it's similar to these queries, but not very similar. So let's try choosing a query that's similar so we can ask it something related. So for example, let's see. So this one is talking about RAG chatbots. So I'm just gonna use a query that has like something related to RAG. So I like recommendation systems. And let's see what the new query looks like in the plot that we have. Okay, so this one that's talking about learning more about search. Let me see if I can make this full screen. So hopefully you can see it a bit better in there. So this one's talking. Let me pan in here. This is my query that says I want to learn about. I like recommendation systems, and then this one is the closest one. And the text says, I want to learn more about recommendation systems, which is very similar. And then we also have this one that's related to CS. We have a couple more in here that are related, but you can see that the closest one is this one, and then it has these other four in here. So let's try a new final query that we can ask for. For example, favorite animal. And now let's plot this one in here. Okay, so in here, here's my query, and then we have these two that are similar that says, that talks about cute plants, and then this one talks about flowers and liking bees. So it's kind of similar. Then it's also similar to this one. And then this one that talks about I love dogs, which is also an animal, which makes sense. And then we have this one from Ibrahim that I'm not pretty sure what the query says, but we can see in here. Ibrahim. Oh, it's just a name. All right. Okay, so to wrap up, I'm gonna try the application that's deployed so you can also test it in there. Let me just check that everything was deployed smoothly. Why is it not showing? It should be updated now. Like it should be showing, okay, let me go to the code and see if it was actually like updated. Yes, it's there. Then why is it not being updated on Streamlit? I mean, you can always do the redeploy, reboot app, so we can get like the updated changes, and you can also test it on your computers as well. And yes, no worries. Okay, while this is being deployed, if I go to my repository back in here, you can feel free to add new features onto this app. I'm gonna add the Streamlit page in here, so you can also have it in handy. This one, the slides that I was sharing, you can find them in here. I'm gonna be updating this readme because it's a bit updated. I mean, it's kind of accurate, but it also has some things that are not there anymore. It has all of the code in here. And then you can also feel free to open up like a pull request in case that you want to add a new feature. And then I'm gonna be reviewing this. I already left a review for this one. So yep, and that will be all for this. Let me just check how this is going. Great, so now it shows the two pages that we have. So if now you go ahead and test the app, you should be able to see like the new page that we just created. Let's just check if we can actually try it or if there's like any error with the requirements. This app has okay, so we need to include these on the requirements. So something strict about Streamlit is that you need to have a requirements page with all of the requirements that you're going to use. So in this case, I have just added Plotly and sklearn into the requirements. So I'm just gonna add requirements. So I'm doing the commit right now, and once I do the push, then it's gonna update on the Streamlit page immediately. Let me go down. Yep, so it's being processing again. In here, it had an error with Plotly, and I believe it also had an error with sklearn. So I also added sklearn in the meantime. It looks like the dependencies are being generated again. So let's see if and now it works. Also, the updated requirements are on the GitHub, so you should be able to install all of the requirements from there. Okay, so let's just give it a try. I like to read. Just plot this and see if it's working. Keep in mind that if you want to add new information into the database so you can have more things that are being plotted, you can go ahead and add it on the other page. Okay, so it looks like it's working now on the deployed page. And if I go back in here, you can add more knowledge in here. You can also test the knowledge, and there's plenty of things that you can do in here. Great. So that will be all of the steps that we wanted to complete for this stream. As I mentioned, we might have finished a bit early because it was just pretty straightforward and there were no extra features that I just wanted to add in here. We also didn't have any issues with the deployment, so everything just went out smoothly as well. There were not many questions, so I did not have to stop like really often to explain things. Keep in mind that if you want to watch the previous streams about uh, creating your first rack system or building a recommendation system part 1, they are all on the YouTube channel. The slides presentation that I'm sharing with you, you can find it on the GitHub README. And yeah, honestly, that will be all. If you like this stream and you would like to give some feedback, please feel free to fill out this form that's in here for feedback. That's called Global Hack Week feedback. It's just a 2-minute form. It's really straightforward. If you also like to add more things or improve things or also see new types of streams on upcoming Global Hack Weeks, feel free to comment all of that in there. And yes, thank you for your time as well. And so glad that you enjoy it. This is going to be my last stream for this Global Hack Week, but I will be back next year on January with a brand new set of streams on Beginners Week. I actually just submitted my topics, which are going to be super interesting. So I'm going to be giving introduction to Arduino. I'm going to be giving introduction to embedded systems and introduction to assembly, I believe. So if you want to learn a bit more about robotics and not only like the AI side, I'm going to be now talking a bit more on Beginners Week about robotics and a bit about digital systems and embedded systems as well, with some electronics mixed in with Arduinos. So yes, that's what's going to be upcoming for me on Global Hack Week. I'm going to be giving plenty of streams next January. So feel free to stay tuned, and all of the updates are going to be sent on the Discord channel. Thank you everyone again for your time, and I will be seeing you next year. Happy holidays, everyone. Bye.